Right, to prepare salts, you must decide which method you are going to use. That means you must know that the salts that you are going to prepare is soluble or insoluble. So that's why you must remember the table mentioned in your textbook page 12, or otherwise you cannot choose the appropriate method for preparing the salts. Next, if you want to prepare salts, of course you need to choose an appropriate reaction or appropriate reaction so that the salt is produced first. Okay, and then you need to consider whether the salt is pure or not. So that's why you need to do some separation or purification steps. Okay, these will be some experimental steps. But first, primarily, you must know the reaction that can produce the salt that you want. We will start with the insoluble salts. That will be easier, or you do not have a choice. Because you just have one reaction to give the insoluble salts, that is precipitation. But remember, for lockstep for precipitation reaction, you have the aqueous solutions. That means the ions are dissolved into the water. When they mixed, they form an insoluble ionic compound. Right? So that's why when the ions are moving in the solution randomly, when they mix a counterpart which can form a very strong ionic bond, then they will become insoluble in water. So that is a chemical change, right? Because these ions change from soluble to insoluble. Right? That is a change. Right? But when you mix two aqueous solutions, but no insoluble solids are formed, then that is not a reaction. Remember, that is a very important concept. Right, so look at this schematic diagram. You need to first mix the two solutions to have the reaction. Then next, you need to do some separation and purification. So since the solids formed is what we want, then we do the filtration and then collect the residue as our products. But before that, we know that some ions that present in the solution may stick on the solids formed. For example, the original reactant. Right, so that's why we need to wash the products that we form by a large amount of large amount of water. It doesn't matter whether we use. We do not need to worry about the fact that the washing will dissolve the products that we want, because the products that we want is insoluble. Right, so that's why washing the products with large amounts of water just clear or remove the soluble impurities. So when you are answering the question, you must say that we are removing the soluble impurities. So for the insoluble impurities, then we cannot do much, right? Because the products that we want is also insoluble. Right, so we do not do anything about the insoluble impurities by washing it by the large amount of water. So since we have washed the products by large amounts of water, then the products would be mixing with some water molecules. So that's why at last we need to do the drying step. Right? The drying step can be done by three common methods. First, using filter paper, or drying it by the filter paper. Or just like when we use tissue to clean the wet tables, or we can put the products into an oven using high temperature to remove the water molecules. But note that this method will have a limitation. That is, some compounds may decompose at high temperature. For example, some metal carbonates will decompose at high temperature to become the metal oxide and carbon dioxide. So in this case, if you use the oven serving the drying purpose, but accidentally the products will be decomposed, then that will be contradicting to what we want. So the second method is using the oven. Then the third step is using infrared lamp, using the infrared waves to clear the water, to remove the water molecules. So infrared waves is actually heat. Okay, so that's why it helps to remove the water molecules as well. So let's look at an example in your notes. So as we want to produce lead-2 sulfate, which is an insoluble salt, then we need to find out two solutions. One of them containing the cation, another of them would containing the anion. Right? Then when we mix them, the cation and the anion can move in the solution randomly. At last, when they match, they would form a strong ionic bond that cannot be separated by the water molecules. So that's why it becomes solid, and this is a chemical change. So here, the sodium ion and the nitrate ion does not involve into the reaction. So that's why they are called spectator ion. So you can see from the ionic equation, we are just mixing the lead-2 plus ion and the sulfate ion to form the lead-2 sulfate solid. So in order to dissolve the lead-2 ion and the sulfate ion into the water, then we need to find some salts that is soluble but containing these two ions. So the most common anion that we use can make all the metal ions dissolve would be nitrate ion, because all nitrates are soluble. Similarly, if we want to make the sulfate ion soluble into the water, then we can use some sodium ions, or we use sodium compounds, because sodium compounds are all soluble in water. So that is why we choose these two ions, right? Although they are not involved into the solution, but usually we will use these two ions for precipitation. So we first mix the two solutions as a source of the lead-2 ion and the source of sulfate ions. They must be separately present in the two solutions, or otherwise they are insoluble in the water, right? So secondly, we stir it, okay, to speed up the mixing of the lead-2 ion and the sulfate ion to form the precipitates. Then after the precipitate is formed, and filter it and collect the residue as a product. But before that, we need to wash the precipitate with a large amount of distilled water, so as to remove the soluble impurities. You must write the soluble to indicate that only the soluble substance is removed. Then we need to dry the precipitate using filter paper or oven. So this time you are going to produce silver chloride, which is an insoluble salt. So please fill in the blanks here what you are going to do. Try to learn how to write the procedures. This is a very common question in the public exam. Okay. So also you need to draw the diagram here, step 5, in order to help you to know what are you going to do during the experiments. Okay. So the key step here, you must weigh the blank filter paper before you do the filtration, or otherwise after you collect the products, then the products are mixed with the filter paper, then you cannot find out the accurate mass of the products, right? Because when you even weigh the final mass of the filter paper plus the product, then you cannot remove the product completely to weigh the blank filter paper again. So also revise how to calculate the percentage yield. That will be equal to the actual yield, that is the mass that we obtain in the experiment, over theoretical yield, that is calculated by the mole ratio from the equation. Assume all the products are collected 100%. Remember how to do the percentage yield.